Diviner's primary strength is its ability to very accurately map the temperature of the lunar surface.
Diviner has several experiment goals. The broadest and highest goal is to characterize the thermal environment of the moon. The moon has three different types of thermal environments. It has a daytime, which is dominated by the radiative balance between the lunar surface, which is being illuminated by the sun, and nighttime, where everything is cooling off because there's no source of heat other than the subsurface. And thirdly, the polar region, which may or may not have illumination depending on the topography. And so in the polar regions, you can have areas that are permanently illuminated or permanently shadowed. For most of the lunar surface, which is essentially in vacuum, water would evaporate or sublime very quickly. For areas near the poles that are nearly permanently shadowed, the temperatures are much colder, and the temperatures can actually be so cold that water ice would be stable on the surface.
One of the very interesting questions that Diviner hopes to answer during its mission is whether there is any water ice trapped in the really cold areas of the moon caused by permanent shadow. This has been something that's been thought about since the early 1960s, actually, when in preparation for the Apollo missions, planetary astronomers started looking at the moon and noticing that because it's not tilted on its axis very much, there's places near the poles of the moon where the mountains cast shadows and the crater walls cast shadows, and sunlight never gets to the surface, ever. These places are very cold and could in fact be some of the coldest places in the solar system. But if the temperatures in these permanently shaded areas of the moon are cold enough, it's possible that not only water ice is trapped, but other compounds as well. And these would give us additional insight into kinds of things that are flying around the solar system from its origin onward. And so this is really not a question so much just about the moon, but about the evolution of the solar system itself. So Diviner has already returned some really exciting data from these permanently shaded areas at the poles of the moon. You know, we ran some models years ago that predicted temperatures on the order of about 100 Kelvin. If temperatures are above about 100 Kelvin, we lose interest because water ice could probably escape. If they're below 100 Kelvin, we get really excited because water ice and other compounds could be trapped there basically forever. And we predicted temperatures below 100 Kelvin with our models, but now Diviner is actually revealing that in fact temperatures are there below 100 Kelvin, maybe even tens of Kelvin below that. So we're getting pretty close to basically very cold, like the coldness of space. So one of the goals that the Diviner team has is we have developed a very sophisticated three-dimensional model of the moon that we can run and predict the temperatures that we are measuring with Diviner. And so Diviner becomes the tool that we use to tell us if our model is accurate or not. And the goal is to get our model accurate enough so that just like a weather forecasting model on Earth, we not only can run it for what's going to happen tomorrow, but we can run it for what's going to happen 1,000 years from now or 1 billion years ago, and really then unlock what we think the history of the moon might have been. The Diviner instrument also has a goal of measuring the properties of the lunar surface as interpreted through the temperature.
For surface properties, we have two separate investigations. The compositional investigation, which I am generally working on, seeks to determine what the differences are between the surface materials.
So for example, if you're at the beach sand gets really hot during the day and cold at night, but on the other hand, a big chunk of rock that you may be laying on up in the mountains is pretty much the same temperature most of the day and most of the night. And so what that tells you is that by measuring the temperature of surfaces on the moon over a lunar day, you can derive whether surfaces are made of rock or made of more loose material like sand.
The second surface investigation is called the thermophysical investigation, and here we use our temperature data to determine the rock abundance, how rocky its particular area of the lunar surface is, or how much soil it has. We also look at how rough the surface is on a small scale.
We can map rock abundance with Diviner. And so we'll be looking at places that potentially would be target landing sites and seeing whether they're safe for landing or not. One thing that's very exciting about the Lunar Reconnaissance Orbiter mission is that it's not just a scientific mission to the moon, and we're all scientists here on Diviner, and that's sort of our interest, but what is exciting is that we play a part in a larger role of really humankind's return to the moon. Part of what we're doing with the Lunar Reconnaissance Orbiter is remapping the moon and learning new things about the moon that we didn't know before in order to help plan these human missions.